Hello and welcome to an easy turn demonstration. So as you can see, the solid model has some OD work. It has milling on the flats here, and we have a drilled hole, that's a through hole, and then we have bore work to do. So we're going to machine both sides of the part as well. So a subspindle coordinate system will be involved. So what I want to do is I want to position this for turning, and I'm going to snap to the front face. We're going to machine this side first. So I'm going to go to View, World UCS on Geometry, go to Discrimination, and that's going to tell me what I'm selecting, and I'm going to select only circles. And do a top view. We're going to go to Rotate X, 90 degrees. Make sure Z, X, and Y are 0. Select our part. Now we're in position for turning. So we'll turn this side. And what I want to do is I want to get the profile by using a silhouette boundary. And we just call this OD, because that's what we're going to start with. Select our part, and that blue line you see here is our path for the tool to follow. Now that I've got that, for turning I don't need to see the solid model, so I'm just going to go blank, Surfaces and Geometry, All, and we'll build our path. I'm going to go to the Curve tab, Generate Geometry. Then I can clear the blue path and then build on it. We'll use chain. We'll start here and here. I want to go a little bit beyond, so we're going to switch over to linear. I'm going to right click twice. That gives us our coordinate system in Z and X. I'm going to just go negative 0.05 beyond. So it gives me a little bit of an overhang. Our next step is to go to turn, and then we're going to use the turn, rough turn. The heavy yellow region is rough material. Rough OD main, and this is the main spindle. You can go to your library and you can pick a tool. You can even create tools in the library. Tool number 1. Our index location. Your post processor could be modified so that it goes to a machine home position instead of an index position. But to save time, we're going to come off the part, and you can shorten that distance up so your tool changes are a little quicker getting to the part. We're going to leave a finish allowance on this part, and I'm going to make it uniform on both X and Z. You can see that I've clicked on this dialog and the graphics updated, giving me an explanation for that field. Units per revolution, constant surface feed. Now what is undercut check? If I had a groove on the part, I could use the path curve throughout the part and then just check this box, and you can see that the path is modified so the back side of the insert isn't going to gouge into the groove. Verify our machining. Now that was one rough pass. Let's say I didn't want to go to a depth of 0.1, but we'll go 25 depending on your type of material and the insert itself. So this is just an example. So let's say I have rough material on the OD as well, and I want to add a rough pass to that. So I just go back into my work step, double click on the list box, stock curve. We're going to change that from the curve itself to manual. I like to hit calculate. The outer diameter, we're going to change that to 0.6. Now we'll verify. we have a 3D preview so you can actually see what the part is going to look like as you machine it. Now notice I didn't have to define the stock. We go by based on the path that we're working with. So as I build more paths, you'll see the stock will grow. Or you could come into automation, 3D simulation stock curve, and you can define your stock. Now we'll go back in for a finish pass, and that would be a profile. And we'll just call this finish OD main. Remove the finish allowance. Now our engage angle, if you look, the engage angle is at 90 degrees, so it'll be coming straight down. That's a little awkward, so we're going to change that to 0. We'll start at our clearance and then feed right onto the part. I'm going to put my cursor on the left side of the part on the ID. Click. Gives me my coordinates. I want to drill about 1 inch deep, and my ID is about 200 thousandths. So if I build my curve first, I want to put a point on the front face on the center of the part. You give it a point because you can put a point anywhere on the front face to drill with live tooling, or even on the side of the part. We'll call this drill. We'll use a linear or rapid move, either one is fine, and come on to the center of the part. The next step is to go and create a drill work step. We'll pick a tool from our library, and we're going to use the 0.157 here. Give it a tool number. Turn off the constant surface feed. And I'm not worried about speeds and feeds. That's something you're going to determine based on the carbide tool or high-speed tool, the type of part material. The depth is 1 inch. We don't need to use a negative sign. We know that we're drilling in the Z negative. I'm going to add a peck. Let's add 0.125. The second peck we'll leave at 0. And we'll verify. I turned on show tool. We can do a 3D preview. I used a 3/4 view, cutting it out so I can see the bore. 3/4 section view. Now we'll add our ID curve. Well, let's do this out of order, and I'll show you what ends up happening. So if I go to turn, profile is used for both ID and OD. So we'll say ID rough main. I'm going to leave the tool number out. I'm going to show you why in a minute. The maximum depth, let's say 20 thousandths. And that's based on our total stock depth cut. I'm going to tell it that there's maybe 50 thousandths of material, and we're walking into it maybe every 15 thousandths, just as an example. Now the offset direction, if I start my path here and I go towards the end, I want my tool on the left hand side. I'm going to pull up our spreadsheet, and just like your machine table, at a glance you can see what's going on. Here's our tool numbers, so I need to have tool number 3 for the drill. If you're using coolant, you can turn it on to flood. You can change any of these values. It gives you a time per operation and then a total time, and it takes constant surface feed into consideration. Now we'll build our curve. Let's call that ID. Curve chain, so I can select the front, then the back, and it changed the whole thing. Now if I verify that, nothing happened. The reason being, if I look at the status of my path, it's using the drill curve. If I had built this curve before I created the operation, it would have known to use it. So to force it to use that curve, I'm going to go down to path. This is my status area, and I'm just going to select my ID curve. Verify. Let's add a facing operation. It's a little out of order, but I'm going to show you why we're doing this way. So I'm going to go to curve. It's going to be a linear curve, and my z is going to be 0. My diameter is 0.5. We'll just add 50 thousandths. That's our start point, and then we just take the x and go to 0. Then we'll go to turn and face profile, and we'll call this face main. It's going to be on the left side. Clearance is 100 thousandths, and gauge angle is 0. Depth of cut, we're just going to take a finished pass, so there's no total stock or depth of cut. Constant surface speed. Look at our tool. Use our turning tool. That'll be tool number 1, and verify. Okay, that was out of order, so I'm going to go in the list box and I'm going to click on face main, and I'm going to use my left arrow key and make that my first operation. Let's show our model. We want surfaces and geometry. And you can see that the flat is on the world coordinates, so if I go to the world coordinates and do a top view, you can see that we're going to machine straight across. If the part was oriented, you could have the flat at the top. When you use the curve silhouette boundary and the curve was on the top, the flat was on the top, the silhouette boundary spins the model and gets the high points, so you can do your turning operation. So the next step would be to create a new curve. Linear is fine. We're going to snap here to here. Go to mill turn. That's curve milling. Mill flats main. Tool number 4. If you're using cutter comp, you put in an offset. The diameter of the tool, let's go with a 1/4 inch. The surface, so we're working off of 0 with milling, so the coordinate system's at 0 on the center of the part, so we need to come up by the radius. So it's a 1/2 inch diameter, so we're going to come up by 250 thousandths. We'll give it a rapid, and then instead of feeding from the rapid, we'll give it a clear, so we'll come down to 100 thousandths over the flat. The depth of cut, the curve is at the depth of the slot, so I can keep that at 0. Let it calculate for me, so I didn't even have to measure that. The location is on the side left. Left meaning main spindle, right would be the sub spindle. And our coordinate system is not the side. If it was the side, it would be at the top, so we're going to change that. We're working on the world coordinate system. We're going to use a contour operation. My curve started here and came down here. I want my tool on the left hand side. The finish allowance, let's give it a negative finish allowance, 0.03, so that I get an overlap of the tool instead of being tangent to the edge. If you're using a y-axis, it's as simple as just putting a check in the checkbox. That's pretty much it when you're working with a y-axis. EasyCam takes care of the rest. Machining and verify. You can see the yellow region is our tool. It's got the over travel for us, and it cuts the whole width. Now if we look at that closer, you can see our tool, the center is starting right on the part itself. So let's start outside. So we'll come back in here, and we've got another flat 180 degrees. So we're going to work on both those things. So back into the work step, lead and ramp. That would be a radius and arc onto the part. You can combine the two. We're going to go lead in and out with a straight line, and we're going to use half the tool. Let's go a little bit beyond that. The angle is going to be 0, the out angle is 0. Now we go to copy options. We're going to use an increment angle of 180 degrees, and we're making 2 copies. Now the 3/4 cut is going to interfere with our flat, so we're going to go in and we're going to make sure that that's off. Do a 3D preview. And now for our drilling operation. Let's get the diameter and the depth of the hole. Let's figure that out. So we're going to go to dimensions, check distance, snap to all, zoom right in on it. It gives me a depth down here at the lower right corner, 130 thousandths. So we'll go 150 with our drill. Now let's check the radius, and that's about a 50 thousandths radius, so we'll just go with 100 thousandths on the drill. Make a new curve for our drilling. Snap to circle center. Go to our turn mill, and that'll be curve drilling. Tool 5, offset 5, and that'll be 0.1. Surface stays the same, rapid and clear. Depth of cut, we want it to go 130 thousandths at least, and we're going off the 250, so we're going to want to go deeper than that, so we'll go 0.165. This is going to be on the side left. World coordinate system, y-axis output. Tilt that a little bit. Now you don't have to concern yourself with, as long as the curve, it doesn't have to be on the OD, it just has to be in the center of the hole. Because what we're doing is we're specifying the radius value at the top of the hole for the surface. So if we put that together, that concludes the main spindle. Okay, to work in the sub, we go down to the status area. You've got UCS World, click on that. Come over to the list box and pick sub spindle. Top view. Okay, if we turn the shading off, you can see our coordinate system is right here on the left side of the part. We just want to transfer it over to the front. So we're going to go to Edit, Move, Snap to circle center. We're going to move it from here over to here, and in the list box pick your red sub spindle. Do a top view, and we're good. So now we'll build our path. Snap to all. And we'll do a little bit of an overlap back here. So we're going to just go in a negative direction, negative 0.02. Now we're going to go to turn. I'll go with a rough turn. Okay, that'd be tool number 7 maybe. We'll look in our spreadsheet. The MCSID, very important. You pick the sub spindle. And the depth, let's go with maybe 30 thousandths. Let's see if I left some rough material. Now we go to a profile. That's going to be on the right hand side. Verify all, make sure we calculate all of our operations. I'm going to speed things up. I'm just going to slide that over to maximum and preview. Let's face off, and we'll just slide that up. So we'll go to new curve, linear, Z0, come down to X0, profile, face profile's fine. Sub spindle, verify. We'll move that up, click on it, left arrow key, and we've drilled through, so we just want to machine. Let's hide our curves. Curve all. We're going to machine from here over to here. Let's go in another negative 0.03. Gives us the overlap profile. That's finished. You can either define your stock, or we can go in and our facing pass use a total stock. And that completes this turn demonstration. If you have any questions or if you'd like to place your order, you could call 508-347-3222. Thank you for watching.